we're going to talk about simplifying radicals. When simplifying radicals, you need to simplify as many perfect powers of the index that you can. So, just a couple quick things to recall for exponent properties. In exponent to exponent, we would multiply. If we have two together, a times b to a power, that's the same as a to that power times b to that power. And then some people like to use rational exponents. So the nth root of a to the m is a to the m over n. Simplifying square roots. So we have the square root of 27. There's a couple different ways to do these. 27, remember, we can prime factor, so that's 3 times 9, which is 3 times 3. So 27 is 3 cubed. So this is a square root, so we need perfect squares. So 27 is 3 cubed, so that's the same as saying the square root of 3 cubed. But we want perfect squares, so we have the square root of 3 squared times 3. 3 squared times 3 is 3 cubed. Now, if we have, this splits up, because this is an exponent, the radical is an exponent, that's the square root of 3 squared times the square root of 3. The square root of 3 squared is 3, and we can't do anything with the square root of 3, so we're just going to leave it as the square root of 3. So the square root of 27 is 3 square root of 3. 24 is going to be 2 times 12, which is 2 times 6, which is 2 times 3. So 24 is so the square root of 24 is 2 cubed times 3. But we want perfect squares because this is a square root, so that then we want to change it to the square root of 2 squared times 2. 2 squared times 2 is 2 cubed times 3. So then we can take the square root of 2 squared, and since 2 times 3 aren't perfect squares, we can actually just keep them together under the same square root. The square root of 2 squared is 2, and 2 times 3 is 6, so we take the square root of 6. So our final answer is the square root of 24 simplifies to 2 square root of 6. The cube root of 48 is 3 times 16. 16 we know is 2 to the 4th. So the cube root of 48 is the same as saying 2 to the 4th times 3. But since this is a cubed root, we want the perfect powers of 3 in here. So instead of splitting this up into 2 squared and 2 squared, we want it to be the cube root of 2 cubed times 2 times 3. Then that's the same thing as saying the cube root of 2 cubed times the cube root of 2 times 3. The cube root of 2 cubed, just like the square root of 2 squared, the cube root of 2 cubed is equal to 2. And then neither of these are perfect cubes, so we can leave them as is and make it the cube root of 6. The cube root of x cubed is just x. But now we have the 4th root of z to the 4th. Remember that if we have -1 to the 4th, that's equal to +1. And +1 to to the 4th is also equal to positive 1. Unfortunately, we can't have negative numbers under this root because even with even roots, because it doesn't make sense. We end up with complex numbers. So if we have an even root, we have to take the absolute value because we want whatever is positive out of here. Whereas if it was an remember before it was the cube root of x cubed, well, -1 cubed is equal to -1. So the cube root can have negative numbers. So we don't need the absolute value. Even roots have to have positive numbers because otherwise it doesn't make sense. It's similar to the order of operations. It doesn't make sense to have two values come out of one thing. So we have to have the absolute value here. So these are it's the 8th root of x minus 4 to the 8th. 8 is even, so we have to have the x minus 4. But if the power and the index are the same, it's just what's underneath. So the 8th root of x minus 4 to the 8th is the absolute value of x minus 4. Now we have 24 x to the 5th, z to the 10th. We did 24 earlier. Recall 24 was the square root of 2 cubed times 3. And then we have x to the 5th and z to the 10th. We want perfect squares and as many as we can get. So we're going to have the square root. I'm going to make it big because there's a lot under here. We did 2 squared times 2 for our square root of 24. 2 plus 1 is 3 times 3. Now we want perfect squares to get to x to the 5th. So that's going to be x squared times x squared times x. 2 plus 2 plus 1 is 5. So x squared times x squared times x is x to the 5th. Same thing here. We want to do the same thing with the z's to get to z to the 10th. So 2, 4, 6, 8, 10. So z squared times itself 5 times is z to the 10th. So now we can take out our perfect squares. Our perfect squares are going to be 2 squared, x squared, x squared, z squared, z squared, z squared, z squared, z squared. So the square root of 2 squared is 2. The square root of 2 times 3, we're just going to put that over here and make it 6. If you want to, you can split all of them up. But if you don't have to. You can do something similar to what I'm doing. Now we have the square root of x squared, and we have the square root of x squared. The square root of x squared is x, and this square root of x squared is x. So it's x times x, which is x squared. Let me do that in green right above. So this is the square root of x squared and the square root of x squared. This one is x and this one is x. X times x is x squared. This x doesn't have a squared on it, so it has to stay under the square root. And now we have the same thing happened here, only we have 5 z's come out. So this is going to be z to the 5th. because the square root of z squared is z, but there's 5 of them, so it's z times z times z times z times z, so that's z to the 5th. So the square root of 24 x to the 5th z to the 10th simplifies to 2x squared z to the 5th square root of 6x. I'm going to erase everything so we can do the next problem. So 45 is 5 times 9, so that's going to be 5 times 3 squared, y to the 12th. This is a square root, so we need perfect squares, so that's y squared, y squared, y squared, 2, 4, 6, 8, 10, 12, and then z to the 11th, 2, 4, 6, 8, 10, 11. Now we want to take out our perfect squares. We have this, we'll put our square root over here. 5 isn't a perfect square, so we're going to leave it under the root. 3 squared, the square root of 3 squared is 3. The square root of y squared is y, and we have 1, 2, 3, 4, 5, 6 of them. So it's y to the 6th. The square root of z squared is z, and we have 1, 2, 3, 4, 5 of them. So it's z to the 5th. And then we have this extra z that we leave under the root. This is 4th root, and this is cube root. We're going to do the same thing, only we need perfect 4th powers for this one and perfect 3rd powers for this one. So first off, 162 is 2 times 81. 81 is 3 to the 4th. So this is the 4th root of 2 times 3 to the 4th. So we have a perfect 4th power. So then u to the 10th we want to split up into u to the 4th times u to the 4th times u squared. 4 plus 4 plus 2 is 10. 4th root, 4th power. So now we have the 4th root over here. The 2 doesn't have an exponent, so we're going to keep it as 2 out here. The 4th root of 3 to the 4th is 3. The 4th root of u to the 4th is u, and we have 2 of them, so it's u squared on the outside. And then we have the 4th root of u squared. We can't do anything with that, so we're going to leave it as u squared. Same thing with this one, only we want perfect cubic powers now. So 250 is 2 times 125. 125 is 5 cubed. So we're going to have the cube root of 2 times 5 cubed. And then we want perfect cubic powers, so that's v cubed times v squared. 3 plus 2 is 5. So now we have, oops, I don't want that there, I want to move it over. The cube root out here. The cube root of 2 we can't do anything with, so we're going to leave it under the root. The cube root of 5 cubed is 5. The cube root of v cubed is v. And the cube root of v squared we can't do anything with, so we're going to leave it as v squared. Couple more. We figured out earlier that 48 was 3 times 16. So that is 3 times 2 to the 4th. We want perfect 4th powers, so we're going to do t to to the 4th times t to the 4th. That's 8, 12, 4, 8, 12, 6, 4, 8, 12, 14. And then we want to do the same thing with the u. So u to the 4th, u to the 4th, u to the 4th, and u to the 4th. So that's equal to, we need the 4th root out here, the 4th root over here. We can't do anything with the 4th root of 3, so we're going to leave it under the root. 2 to the 4th root of 2 to the 4th is 2. The 4th root of t to the 4th is t, and we have 3 of those, so that'll be t cubed. The 4th root of t squared we can't do anything with. And then we have the 4th root of u to the 4th, which would be u. And we have 4 of those, so that's 4. I'm going to erase that and show you one other way to do these. And I'll do that same method for both of these. So recall that the 4th root of 48 t to the 14th u to the 16th can be written in exponent form. That's 48 t to the 14th u to the 16th, all to the 1/4 power. I'm going to split up the 48 to be 3 times 2 to the 4th times t to the 14th times u to the 16th to the 1/4 power. And this can go into all of these, because if that property says that if it's all to the 1/4 power and it's multiplied, we can make them all to the 1/4. So that's 3 to the 1/4 power times 2 to the 4th to the 1/4 power times t to the 14th to the 1/4 power times u to the 16th to the 1/4 power. And then let's multiply our exponents. If we have exponents we can multiply, so that's 3 to the 1/4. 2 to the 4/4 is just 2. T to the 14/4. And u to the 16/4 is u to the 4. 14/4. 1/4 is a proper fraction. 14/4 is an improper fraction. So we're going to make that into a mixed number. That's equal to 3 and 2/4. So we have 3 to the 1/4 times 2 times t to the 3 and 2/4 times u to the 4th. Sorry, but I have to come over here. The solid numbers, the whole numbers, or the solid exponents, the whole number exponents, are the ones that actually come out of the radical. So that's going to be 2 t cubed and u to the 4th. And then we take the 4th root. 3 to the 1/4 is the 4th root of 3. T to the 2/4 is the 4th root of t squared. So we end up with the same answer we did previously, but in a different way. You can use either way that works for you. So for the cube root of 125 x to the 5th z to the 7th, we're going to do 125 is 5 to the 3rd, and then we have x to the 5th and z to the 7th, and that's all going to be to the 1/3 power. So that's 5 to the 3rd power to the 1/3 power x to the 5th to the 1/3 power, and z to the 7th to the 1/3 power. Exponent to exponent we multiply. 3 times 1/3 is 5. 5 times 1/3 is 5/3, so x to the 5/3 power. And z to the 7th to the 1/3 is z to the 7/3. Now I'm going to write these two as mixed numbers, so that's 5 x to the 1 and 2/3 and z to the 2 and 1/3. So that the whole number exponents come out of the radical, so that's 5 x to the 1st and z squared, and then we have the cube root. X to the 2/3 is x squared under the cube root. Z to the 1/3 is z under the cube root. Again, either of the two ways works fine for me. So whichever way makes more sense to you. Couple more. This is the 4th root of 16, x minus 6 to the 4th. Remember, the 4th root of 16 is 2, and then x minus 6 to the 4th, we're going to have to do the absolute value of x minus 6 because it's an even root. The cube root of 27 times x minus 6 cubed. This is an odd root, so we don't need our absolute value. It's just going to be 3x minus 6 because the root and the exponent are the same. We have the cube root of 27 is 3, and the cube root of x minus 6 is just x minus 6. That's it for today. See you tomorrow.